some people really don't like this conversation, this talk. They say you're right, but it's never going to happen. It seems that some people don't like simple. Ugh. So what I want to talk about is how to take the JavaScript ecosystem, specifically the front-end ecosystem, oh, there we go, thank you, and make it simpler. So towards a simpler JavaScript ecosystem. Notice the word towards. Towards is because this is a vision. This is not something that you can really do today unless you're crazy, or me. But really, it's a vision towards where I think we should be going and not so much what you can do now. Okay, let's talk about the simple past, because back in the days, and I was doing front-end from 1999, it was really simple. You had one HTML file, one JavaScript file. CSS wasn't invented yet, I think. And you just edited the file and pressed F5. I call it F5 tooling. So you edit the file, press F5 or Command R or Control R, and boom, everything works. So yeah, this is the good old days. Let's talk about oh shit, I should update this. 2021, that's Create React App. I did an eject of Create React App to see what dependencies it has. It has so many dependencies, and this is just part of the dependencies, not all of them. And why? And there's more. If you want to look, these are the configuration files the Create React App creates to support building a web app in 2024. Remix, well, we'll talk about Remix and Next.js and Vite and others later. How did we get there? How did we get from a world without tooling to a world with complex tooling? Why did this happen? And I have no idea how much time I'm going to have because the thingy isn't working. Yes. So give me 10 minutes before. So is it inherent complexity? Is it really complex because it has to be? Or can it be avoided? And I believe it today, it can be avoided. So towards a simpler JavaScript ecosystem. Hi, I'm Gil Tayar. I'm really old. I go back to the 80s. I started coding before the idea of front-end was even an idea. I'm going to die a developer probably. I tried the whole management thing, not liking it very much. I'm currently a principal software engineer at Microsoft, working on an amazing product called Custo. Okay, a small but important distinction, because a lot of people, when they hear simple, they start, yeah, React is complex, React is really bad, and Angular is really bad, I love vanilla, stop, that's not what I'm talking about. I love the current web development today. I love React, I love whatever, Solid, Svelte, no, not Svelte, Angular, others. That's not my problem. My problem is not the frameworks. My problem is the tooling. So why is the tooling complex today? And my argument is that the complexity is there for a reason that existed in the past, but is starting to become irrelevant now. It's starting to become irrelevant now. And we will outline those reasons why the complex tooling is there, and we will see that the solutions, the tooling, are causing problems, and these solutions aren't really needed today. So let's talk about complexity number one. Back in the days, you can write all your JavaScript code in one big, 1,000-line file, and you're good because you didn't need a lot of JavaScript. Today, we're talking 10,000, 100,000 lines of code, of apps. JavaScript source gets bigger. And we need modules. We need to split the thing into files, obviously, files and folders and whatever. Unfortunately, browsers did not support multiple files. You couldn't break apart. If you take Java, if you take Node, you can break apart your app, and Node or Java or C# or whatever and Python know how to use all these files together. The browser doesn't know how to do that. So the solution we found was something called bundlers, Webpack, Vite, others. Suddenly I don't remember any of them. Break apart, what does a bundler do? It takes all those files, it goes to the index.js that you have and starts crawling the files and seeing what you're importing and then bundling all of them together into one big bundle.js or main.js or whatever. So that's the problem and that's the solution. Another problem is that JavaScript is wonderful and dynamic languages are really, really good, but the fact that you can't type your code gets problematic after about 10,000, 20,000 lines of code because you don't know what's going on in your code anymore. So TypeScript was invented. TypeScript and Flow and whatever. TypeScript is obviously the big winner here. But unfortunately, nobody understands TypeScript. Browsers don't understand TypeScript. So we had to do transpilation, take this TypeScript code and transpile it into JavaScript. Problem number 3. We have frameworks. And these frameworks has crazy ideas like JSX, like putting HTML inside JavaScript. I remember the first days of React, everybody laughed at that and decided it was crazy. Now everybody's doing it, and probably for a good reason. But it means that we have to transpile the JSX too, because browsers obviously don't understand JSX. So I hope I convinced you that the complexity of the tooling, the bundling and the transpiling mainly, and that is 99% of what the tooling does, is there for a reason, for a good reason. We need them. We need TypeScript, we need JSX, we need bundlers, we need the transpilation and the bundling, we need the tooling. But unfortunately, everything comes at a cost. There are problems. Problem number 1, there's a build step. So builds of sometimes tens of minutes. It's better today, especially if you have a Mac M3 or an i9 Intel, but still it's something that we need to constantly optimize. I know there's a developer at our team that constantly tweaks and optimizes everything around builds. So we have build caches and incremental compilation, and instead of writing the tools in JavaScript, we write them in Rust, which is not very native to our ecosystem. So this adds to the complexity of the implementation and configuration. Incremental compilation doesn't come for free. There's a lot. We all know that sometimes we need to clean that cache and clean that incremental compilation because everything is so complex. And you just can't refresh and try. It doesn't work. You need some mechanism to build while you're refreshing. So you need a watch mode where you watch the files, and if they change, you rebuild, and you don't want to rebuild everything, so you have to do incremental compilation. And again, configuration, etc., etc. If you have one big package, then that's fine. But what if you have a mono repo with lots of packages? Then the tooling becomes really, really ugly. Number 2, debugging becomes difficult. And I have to admit that today I work at Microsoft. That's not really a problem, but still, there is some level of problem when I open up the Chrome DevTools and it takes like upward of 10 to 15 seconds for the browser to say, oh yeah, now I recognize the source, you can put breakpoints here and you can eval and watch these variables. But debugging becomes difficult. Why? Because we're not really debugging the source code, we're debugging the transpiled code. So to solve this, we have source maps and recursive source maps, and there's a great talk by Adir Amsalem about this, I think in this conference, or maybe that's not TLV, I'm sorry. Okay. So source maps and recursive source maps, and browsers need to deal with it, and debuggers need to deal with it. Again, lots and lots of complexity. Number 3, and for me this is the worst. Nobody understands these configuration files. Nobody. I mean, except Max. Hi, Max. I don't, and I'm always constantly tweaking them, not all the way, and it's really, really horrible. Lots and lots of configuration files. You have to tweak them and work with them, and only experts understand, and even that. And as an example, this is a bundler. Yeah, obviously. Okay, So video cannot be loaded. So what you'll see here is the documentation of rollup, which is a bundler, and it just goes up and scroll and scroll and scroll and scroll. So it's thousands and thousands of lines of configuration that really nobody can handle. So one, you need to tweak it. Two, if you want to upgrade the tools, you want to upgrade Vite, you want to upgrade Rollup, you want to upgrade Webpack, you're getting into a horror. So people don't upgrade, and that's even worse because not upgrading sometimes is worse than upgrading. So really, this is a horrible, horrible problem. Okay, so people say, yeah, but Remix and Next.js. True, they hide away all the complexity. They tell you, you don't need to deal with that. The problem is that they're throwing it under the rug. They're sweeping it. It's not that it isn't there. They're just giving you something that works. They're sweeping it under the rug, which is fine, but it's a leaky abstraction. If you suddenly want to use Emotion.js because you want CSS in JS, suddenly you need to tweak the default configuration that Next.js or whatnot is using because it's not good enough, and then you need to deal with the horrors of something that isn't even documented. Okay, so it is a leaky abstraction. Basically, and all this is true, but the most important thing, we don't understand how our code works anymore. Probably 5 to 10% of the people here can understand what happens from the moment you do git npm install or yarn install, until the moment you see the app in your browser. What happens? What is the pipeline? What does the tooling do? Nobody really understands it, and it's horrible. It's really bad. And it's not just juniors, even seniors a lot of times don't know what is happening there. And we've become so used to it in the past 10 years, we don't see it anymore. And there's the big, hi, how's the water? And the juniors say, yeah, what's water? So yeah, what's front-end tooling? We don't even know what that is. So let's get rid of tooling. Let's get rid of the most, so let's start with the most complex tool of them all, the bundler. The bundler that takes all that and creates a bundle.js. So let's take a Create React app to a toolless future. In the end, you have a link to the presentation and to the GitHub repo. You have a QR code. You can go to the GitHub repo and see everything. It really works. Okay. So browsers do now, in 2024, support multiple files. It's called ESM, ES modules. It just works. So if you do import like this, it works. You don't need to bundle anything. Well, not exactly. You just have to tweak it a little bit. You have to add the extension, .js. Because browsers can't look at it and say, oh, there's no extension, let's add a .js. Browsers don't do that. They don't guess. So you have to tell it the exact path to the file. Easy, not a problem. But what about bare specifiers? This is called a bare specifier, where you're importing from name of package. Okay, this is not a path to a file. This is the name of the package. In ESM parlance, it's called bare specifiers because this is a specifier and it's bare. It doesn't have a path. Browsers don't understand node modules and all the lookup and all that. They don't, and they don't want to guess, which makes sense. So we could do this, and it'll work. Import React from node modules /react/index.js. It works, but not really nice. But it really won't work if React has imports that are bare specifiers, etc., etc., etc. So it works only for one level, but if it has more levels, it doesn't work. So what do? We use it was new when I first wrote this talk, a new technology called import maps. You do a script type equals import map, and you specify what the bare specifiers mean. You say React is node module /react/index. React DOM is this, and you specify all your packages, and boom, now your browser understands bare specifiers. So supported on all browsers. It used to be supported only on Chrome, and then Firefox, and then now Safari also supports it. and it tells the browser where to look to find files if it doesn't find them. This is great, but there's an itty-bitty snag. React isn't ESM, and most packages that we npm install aren't ESM. They are CommonJS. CommonJS is when you don't use import from, you use require. Why is that? Because npm was created not for front-end developers, it was created for Node developers, and Node developers till about 2-3 years ago didn't have ESM, so no support for ESM. Even front-end packages do CommonJS because that is what npm is there for. It's starting to change a bit. We'll talk about it in a second. But currently, most of the packages are CommonJS. I think it's about, today, of the popular packages, about 20% are ESM, which is really, really good, but we're not there yet. So you can't really import from React. It won't work. What do? We have esm.sh. esm.sh is a CDN. There are others. I just used that as an example. Unpackage is another one. There's like 5 or 6 of them. And what you do is instead of pointing to your Node modules, you point to a URL there, and it knows how to on-the-fly transpile from CommonJS to ESM, and it has caching and it's a CDN, so this is really, really great. You can specify specific versions, whatever you want. So the import map isn't into Node models, but it's to esm.sh, to the correct version. And note that this isn't a build. It's a smallish build. Whenever you npm install a new package, then you need to add to that import map. That is all. It's a step that you do when you npm install. So the future, we won't even need esm.sh because all packages will be ESM. npm packages, as I said, note that, let's ignore that. And that's it. Okay. We figured out bundlers. No more need to bundle the file when the browser picks up your index.js, everything just flows and ESM handles everything correctly. This is really nice. So a whole level of complexity, and bundlers are the most significant complexity, a whole level of complexity thrown away. So we don't need bundlers anymore. We use browser-native ESM, import maps, and if something is in CommonJS, we use esm.sh. If you have your own packages, like in a mono repo, well, those can be ESM. They don't need to translate to CommonJS. They can be ESM native, so you don't have problems there. We still have to take care of JSX and TypeScript. So let's start with JSX. How do we remove JSX transpiling? Okay, so there's a package called HTM. It's a wonderful, wonderful package, and it really works. You do HTML, backticks, and then you put your JSX inside it. It supports syntax coloring. It could support types. It doesn't. Ouch. As I said, it's a vision. Don't use this at home, please. But it works. You just backticks, and it knows how to, on the fly, figure it out and transform the JSX into react.createElement, which is what JSX does. No need for transpiling. Now, a lot of people will say, but this is good for dev, it's not good for production because you don't want to do this on the fly. And they're right, because everything I've said till now is great for dev. We'll talk about production later. So this is almost as nice as JSX. I wrote a small, nice front-end app with that, and it really works. It's really, really nice. So we've removed JSX. Now for the big one, TypeScript. How can we remove TypeScript? Okay, so let's take a function. This is a function, add, return A plus B. This is the same function with TypeScript. It used to be that I had to go to a conference, I needed to explain what TypeScript is. I'm assuming everybody knows what TypeScript is. So this is a function with TypeScript. This is great, but what's the problem with this? It needs transpilation. Now let's take this. We add what are called JSDocs onto it, add param number A, add param number B. So we're specifying the type inside the curly braces. We're specifying the type of these parameters, and we're specifying it as TypeScript types. Any TypeScript type can be used in there, no matter how complex it is. And this doesn't need transpilation, but will be checked by the TypeScript compiler exactly as if it was TypeScript. So we will get all the squiggly lines, and you will get all the TypeScript errors and everything if you just use an alternative syntax. This is basically an alternative syntax endorsed by Microsoft. And I'm not talking here as a Microsoft employee, I'm talking here as a TypeScript fan. Endorsed by Microsoft to support all the syntax of TypeScript. You can even do complex TypeScript type. For example, you can type a new type, which is an object which has age number, and say that people is an array of people, and everything just works in TypeScript. So we get all the benefits of TypeScript without the drawbacks. And what is the main drawback? Transpilation. You just get all the benefits. Almost all, because it's clunky. I mean, I love not transpiling, but it is a bit clunky to write JS docs and not TypeScript. But it works. And in the future, there's hopefully, I have to say it's a bit stuck, there's even an even better solution. There is ongoing work in TC39, the JavaScript standards body, to enable syntaxes like TypeScript, syntaxes that have type annotations, to be part of the JavaScript standard, so which means that this will be standard TypeScript. It's standard JavaScript, and browsers will recognize it. They won't care about the types. They will ignore the types, but they will run it. So, no transpilation for TypeScript. So given this, we have our holy grail. Front-end code that needs no transpilation and bundling. TypeScript code using ESM, JSX code using HTML, being served by a regular web server without a build step, zero build step, no need for incremental watch or whatever. Change the code, reload, and you're done. Okay? You can still have very simple build steps, import maps, CSS modules, etc. If you want to see the GitHub repo, you can do that. Note that once they've become simple and not part of a huge configuration, and it's something that you configure, they become a really simple part of this, of the whole thing. But obviously, we're not there yet. Okay? This works, but HTML doesn't have type checking, the backticks doesn't have type checking and everything, but it's a step towards. It's to say, look, you don't need tooling. Let's try and figure out a way to do things without tooling. We'll talk about production later. So, can this be used in production? Ooh. Maybe. There's an elephant in the room. Let's talk about the elephant. If you try and run an app that has ESM and loads everything via ESM, what you will get is hundreds of files being HTTP gotten. HTTP get, HTTP get, HTTP get. A lot of files. Hundreds of imports, sometimes thousands of imports. That's not, in the real world, that doesn't make sense. It just doesn't make sense. It's it's part of the reason why people use bundlers. Not just because they have to, but because in production, they must. So first of all, the fact that it's a must in production doesn't mean that it's a must in dev. Just like minifying your code is a must in production, but you don't do it in dev. You do it only in production. But can we solve this? Can we solve the problem of ESM being heavy on HTTP? I have 5 answers to that. So first of all, why? Why solve? Why not just bundle and everything? Because bundlers, even in production, are problematic. The first thing, and probably the most problematic, is every deploy you do to your app invalidates the browser, the user's cache, and means that they need to reload all the app, the 5 megs or 10 megs or 7 megs of your cache. Why is that? Because even if you change one little file, When you create a bundle, it doesn't just create bundle.js, it adds a hash to the bundle so that you can expire forever the file, so that the bundler doesn't need to check if the file has been changed. But if you change one single file in that bundle, the bundle hash changes, which means you have to download the whole bundle again. So what do we do? Lots and lots of solutions. One of the solutions, and this has nothing to do with invalidation, but also you don't want the user to download 5 megs, is bundle splitting. And bundle splitting is an arcane art. Nobody really knows how to do it well. And you constantly need to tweak the configuration every few months or so to make sure that everything is fine. And it's the users that suffer this time from these two problems, not us. The users from bundling, which is supposed to be the great solution to performance. Let's look at other solutions. This is a typical dependency tree. So what we can do, what ESM does, is it parallel loads everything. So it loads file 1, and then file 1 has 2 imports, so it loads 2 and 2 in parallel. And then after it loads 2 and 2, it can load 3, 3, 3, 3 in parallel, etc., etc., etc. So there's a lot of parallel loading going on here. It's not really serial. HTTP 1, even if it was in parallel, it doesn't work because there is no parallelism in HTTP 1. HTTP 2 has much better parallelism than HTTP 1, but it's not yet good enough. HTTP 3's parallelism is really, really good. It uses UDP and all other kinds of things to make the whole loading of parallel files much, much faster. And so loading with HTTP 3 is much faster in terms of ESM than HTTP 1 and 2, and most CDNs today support HTTP 3. But it's still 5 steps. Load 1, 2, 3, 4, 5. It's not exactly that. It's faster than that, but something around that time. But what if instead of figuring out which modules there are, what if the browsers know beforehand what those modules are? Once they load the HTML, then they can load all of them in parallel, or as much as the bandwidth can support. And the answer is yes. Link rel equals module preload. You specify all the files that need to be loaded in your HTML, and you're done. Not only will it load the files, it will also parse them and prepare them for running in parallel with rendering the page and bringing other stuff into it. So this is great, link rel equals module preload. But wait, there's more. Once we stop bundling, suddenly all kinds of stuff enables us to, we get a lot of things for free because we're going the standard way and not making the browser, not faking it with bundles or whatever. Let's look at what happens with link module preload. Let's say I have a get to blog post. It returns the HTML, parses the module preloads, and then gets index.js, gets all the files, and we're done. This is usual step of a browser bringing in the JS files. This is great. In static sites, it's great. But in dynamic sites, this part where you return the HTML is less than 1 millisecond. Just read the file and start streaming it. In dynamic sites, where there's a server involved, a real server involved, this could take a second, even more. Let's say a second. During that time, it can't parse the module preload because it's not getting it. This could be, and this is 1 second. That's a lot of time to bring in JavaScript files. So what do? We have a new status code in HTTP 103 early hints. It's still experimental. No, it's not. Not anymore. It's real. It's being used by a lot of servers. Let's look at what this status does. Let's say I get the blog post or get the to-dos. What the server returns is 103 early hints. 100 status codes can be returned before the real content, before the 200 is returned. So it returns a 103 early hints with headers just like module preload. You just specify all the JavaScript files and CSS and whatever, but what is important for us is you specify all the modules, so now the browser can start loading and parsing the files even before getting the HTML. Once the HTML is ready, we get a 200 OK, and boom, the HTML is back. Woo! So this time, the 1 second time can be used for getting the JS files. And we get caching for free because it's just files. It's just HTTP URLs to the browser. So it's just HTTP URLs and not bundles. Caching just works because if you use standard browser stuff, things just work. If we change just one file in the deployment, only that file will be gotten and not everything else along with it. So we get caching for free. So let's summarize. We can reach F5 refresh heaven without tooling and development today. It works. You can try it out with my GitHub repo. I tried it out in a company called Roundforce before I came to Microsoft. It really, really, really works. Instead of bundlers, we use native ESM, we use import maps, and if the packages are common JS, we use esm.sh for them, and no need for bundling. Instead of TypeScript, you use JSDoc typings or wait for type annotations proposal in 5 years to reach standardization, hopefully. For JSX, use native JS file solutions like HTM that can still be transpiled for production, by the way. There's a Babel transpiler that takes those HTM and turns them into production-ready code. And you can still have very simple build steps. See my GitHub repo for details because I don't have the time. And definitely have build steps for production like OptiMS JSX, minifying, which is crazy important. And we can still do it in production theoretically. HTTP3, link module preload, 103 early hands. There are things called web packaging and other kinds of standards that are bundles, but not really bundles, which are on the way. There's a lot of standardization and thinking going on in the web that will solve the problem of bundling too. And the idea is to also get great caching for free. We're not there yet. I mean, unless you're crazy, don't try it at home. Please don't try it at your company, or people will or CEOs will with pitchforks will come running after me. But please do try it on your own spare time. It's really, really great. That's why it's a vision. It's not more than a vision, but this is a keynote. Hey, so we're good. Keynotes are supposed to be visionary. I want us to get back to our roots. JavaScript is a dynamic language. It does not need to be compiled or transpiled. We've gotten all the disadvantages of compiling and transpiling, and we don't really need them, and we shouldn't want them. We should try and build stuff that doesn't need transpilation and bundling. We needed it back in the days because browsers didn't support stuff, but we don't need it today. Let's get back to our roots as a dynamic language that doesn't need compiling. Let's stop our addiction to tooling, and we are all addicted to tooling, all of us, including, unfortunately, me, and move towards a simpler JavaScript ecosystem. Thank you very much.